Welcome to IDS IT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Have you ever imagined reading a novel on a screen no larger than a postage stamp while jogging? That's not science fiction. It's the challenge facing today's eyeglasses and smartwatches. And today, we are diving into how ultra-high-definition quantum dot displays are solving that challenge and completely reshaping wearable tech. As wearables shrink in size, their displays need to get sharper, faster, and smarter. Traditional smartphone displays top out around 460 pixels per inch, but the latest breakthroughs in quantum dot displays are now exceeding 25,000p. That's not just a spec bump. It eliminates eye strain, blurriness, and the screen door effect that makes low-resolution AR feel artificial. Wearable devices, unlike phones or TVs, demand extreme optical precision. Think of our glasses, they need to show overlays with a wide field of view while maintaining razor-sharp clarity. Smartwatches need high refresh rates to stay readable during motion. And in VR headsets, poor depth cues can lead to motion sickness. It's not just about visual quality, it's about biology, comfort, and real-world performance. But here's the problem. Conventional displays like LCDs and OLEDs aren't built for this. They're too bulky, degrade too fast, or burn too much power at high resolutions. That's where quantum dots come in. Quantum dots are nanocrystal semiconductors that emit bright, pure colors when energized. In 2024, researchers from GIST and UNIST unveiled a major leap. A double-layer dry transfer method that stamps both light-emitting and electron transport layers in a single step. The result? Displays with 23.3% external quantum efficiency and resolutions beyond 25,000 pixels per inch on scalable 8HCM panels. This new process breaks the long-standing trade-off between resolution and brightness. Now, wearable displays can be ultra-sharp and ultra-efficient at the same time. So what does this mean in the real world? In healthcare, Zurich has developed glasses that track eye movement using magnetic nanoparticles, no batteries needed. This helps diagnose neurological conditions like Parkinson's without invasive equipment. At Johns Hopkins, surgeons use SUDAR visors to overlay 3D anatomical maps onto patients with sub-20 micron accuracy, making surgery more precise and safer. In logistics and manufacturing, HoloLens headsets have boosted productivity at DHL by 30%, and BMW's AR systems have reduced assembly errors by 41%. Meanwhile, Samsung's latest smartwatches use 3000p sensors to detect metabolic markers, enabling early intervention for chronic illnesses. These aren't gimmicks, they're real-world improvements powered by sharper, more responsive displays. But power and heat remain big hurdles. Boot screens draw more energy and generate more heat in tight spaces. To fix that, researchers are building solid-state batteries, diamond-based heat spreaders, and even quantum dot arrays that cool themselves at the pixel level. There's also innovation at the edge. MIT is experimenting with phone and laser-based waveguides that project holograms directly onto the retina. The University of Tokyo is developing cadmium-free, self-healing quantum dots that extend device lifespan and safety. And new EU regulations are pushing for displays that dim or pause when users are distracted, prioritizing human safety over constant alerts. Ultimately, wearable displays aren't just about resolution. They're about merging seamlessly into our lives without distraction. With pixel densities approaching 50,000 p, the line between screen and reality is blurring fast. Imagine glasses that translate signs in real time, or notify you of health issues before symptoms even appear, all while staying invisible to the eye. That's the future quantum dot displays are making possible. The invisible interface era isn't coming. It's already here.